Betelgeuse, a colossal red supergiant star situated in the Orion constellation, has fascinated astronomers for decades with its unpredictable luminosity fluctuations. These dimming episodes and the star's non-uniform surface features have fueled speculation about hidden stellar processes. Recently, the James Webb Space Telescope has provided new insights into Betelgeuse, offering exciting details that could finally unlock the secrets of its impending supernova or present even more puzzles about this magnificent supergiant. This article explores the mystery uncovered by the James Webb Space Telescope and delves into Betelgeuse's fascinating life cycle. Stars in the vast expanse of the universe follow a spectacular cycle of birth, life, and eventual demise, each phase unfolding in awe-inspiring ways. Betelgeuse, with its immense size and ancient age, has long intrigued scientists and stargazers alike. Its distinctive reddish hue and fluctuating brightness have been subjects of fascination for generations. Recent developments have heightened curiosity and concern regarding this cosmic giant, suggesting we are on the brink of a potentially momentous event in its cosmic journey. To grasp the enormity of Betelgeuse, one must comprehend its staggering dimensions. This stellar giant dwarfs our Sun by a staggering 764 times. If it were to replace our Sun, its surface would extend far beyond the orbit of Mars, encompassing Mercury, Venus, Earth, and Mars within its reach. This scale not only underscores Betelgeuse's physical grandeur but also reveals its current stage in the stellar life cycle. As a red supergiant, Betelgeuse is approaching the twilight of its existence. It is undergoing expansion and cooling, a phase that follows the fusion of hydrogen into helium within its core. Despite Betelgeuse's age, estimated to be between 8 and 8.5 million years, it stands as an ancient entity in stellar chronology. Over millions of years, Betelgeuse has undergone dramatic transformations, transitioning from a blazing hot blue star to the magnificent red giant we observe today. Stars like Betelgeuse undergo significant changes throughout their lifetime due to the relentless forces of nuclear fusion and gravity. One notable feature of Betelgeuse in its current stage is its distinct reddish hue. This red color results from the fact that Betelgeuse's surface temperature is cooler than that of many other stars, including our Sun. For comparison, the Sun's surface temperature is about 5,500 Kelvin, while Betelgeuse's surface temperature is around 3,500 Kelvin. This cooler temperature allows Betelgeuse to emit light at wavelengths that make it appear red. The red color of Betelgeuse is more than just a visual characteristic, it provides valuable insights into the star's physical state and the processes occurring within its vast gaseous mass. Over time, the color of Betelgeuse has shifted, adding to the star's intrigue. Historical records from the Roman and Chinese eras indicate that Betelgeuse was yellow approximately 2,000 years ago. By the 9th century, Arabic astronomers noted its red hue. This color change is not merely a historical footnote but a significant indicator of the star's evolution. Betelgeuse's changing brightness is another fascinating aspect of this stellar giant. It is classified as a semi-regular variable star, meaning its brightness fluctuates periodically. These variations in brightness have captured the attention of scientists and stargazers for centuries. The star's pulsating brightness adds to its mystique and offers clues about the internal processes and changes it is undergoing. Understanding these changes helps scientists learn more about the life cycles of stars and the complex interplay of forces that shape them. Betelgeuse is known for its variable brightness, typically following a 400-day cycle and a longer cycle of about 5 years. This behavior was first documented in 1836 by Sir John Herschel. Additionally, Aboriginal oral histories may have noted these patterns even earlier. What makes Betelgeuse truly intriguing is its unpredictability. Unlike many stars that dim and brighten regularly, Betelgeuse sometimes deviates from its usual pattern. This irregularity suggests that complex and not fully understood processes are at work inside the star, and its massive size contributes to these mysterious behaviors. In late 2019, astronomers and stargazers worldwide noticed a dramatic and unexpected change in Betelgeuse's appearance. This event, now called the Great Dimming, caught everyone's attention. Betelgeuse, one of the brightest stars in the night sky and a key feature of the Orion constellation, started to dim significantly. It lost brightness at a rate of 0.01 magnitude per day on average. By February 2020, Betelgeuse was at its faintest. Normally visible to the naked eye even in areas with considerable light pollution, it became much fainter during the Great Dimming, noticeable even to casual observers. This sudden dimming led to widespread speculation and concern among astronomers. Some wondered if the star might be nearing the end of its life and about to explode in a supernova, although this is not expected to happen for another 100,000 years. Monitoring Betelgeuse is challenging due to the time it takes for light from the star to reach Earth. When we look at a star like Betelgeuse, we aren't seeing it as it is now, but as it was in the past. The light we see from Betelgeuse today left the star more than 700 years ago. This means we are always looking at its past, making it difficult to predict and monitor rapid changes in its behavior. Andrea Dupree, the deputy director of the Center for Astrophysics at Harvard and Smithsonian, along with her team, closely studied Betelgeuse's dramatic events as part of a 3-year project to monitor changes in the star's outer atmosphere. They used the Hubble Space Telescope to observe this enormous star. These observations provided new insights into how a variable star like Betelgeuse functions. Variable stars change in size regularly, leading to variations in their brightness. Researchers were able to examine the layers above the star's surface, which are heated in part by the star's swirling convection cells, thanks to Hubble's sensitivity to ultraviolet light. Further analysis of the Hubble spectra gathered at various intervals between 2019 and 2020 has provided crucial insights into the dynamics of Betelgeuse's upper atmosphere. These spectra predominantly featured 2 magnesium lines, offering a glimpse into the composition and behavior of the star's atmosphere. Researchers discovered a rapid movement of material from the star's surface into its atmosphere, clocking in at approximately 200,000 miles per hour. As this hot and dense material journeyed millions of miles outward from Betelgeuse, it marked the inception of a dust cloud that contributed to the star's diminished brightness during a 3-month outburst. Dr. Dupree and her team estimated that Betelgeuse's southern hemisphere experienced a loss of material at double the usual rate, raising eyebrows in astronomical circles. While all stars naturally shed mass over time, Betelgeuse's accelerated loss caught attention due to its stark contrast with the relatively stable mass shedding of our Sun. This event sparked discussions among astronomers about the potential for a supernova explosion. The substantial release of mass and the subsequent dimming of Betelgeuse prompted considerations of whether this could be a precursor to a spectacular celestial event. Situated approximately 725 light-years away from Earth, Betelgeuse's proximity adds an intriguing layer to the speculation. A supernova explosion of this magnitude would be visible from our vantage point, offering a rare opportunity to witness such an event up close. However, the lingering question remains, does this episode signify an imminent supernova, or is it merely a transient event in Betelgeuse's complex life cycle? Several theories have been proposed to explain this sudden change. One popular theory suggests that during a supernova explosion, there is a stage where a star rapidly transforms. This idea gained traction because many believe Betelgeuse is nearing the end of its life cycle. Another widely held notion is that dust, potentially originating from Betelgeuse itself, could be obstructing our view. It is known that red supergiants like Betelgeuse shed material which could accumulate into a dense dust cloud, blocking the star's light. A third theory considers changes in Betelgeuse's photosphere, the outer visible layer of the star. This theory suggests that alterations in the photosphere's properties could impact how bright Betelgeuse appears to us. To unravel this mystery, researchers employed various observational techniques and conducted detailed spectroscopic studies. The spectroscopic analysis revealed a decrease in Betelgeuse's effective temperature. This decrease hinted at a significant dark spot on the star's surface, possibly causing the dimming effect. The observed temperature drop of at least 170 Kelvin during the dimming period further supported this hypothesis, indicating substantial surface changes on Betelgeuse. The Hubble Space Telescope, like a vigilant guardian in space, has played a crucial role in unraveling the mysteries surrounding Betelgeuse's peculiar behavior. Through its observations, Hubble revealed that the dimming of Betelgeuse was likely caused by a significant ejection of hot material into space. This material formed a dense cloud of dust that obscured parts of Betelgeuse's surface, resulting in less light reaching Earth. The dust cloud was composed of extremely hot plasma that erupted from a large convection cell on Betelgeuse's surface. As this plasma traversed through the star's hot atmosphere towards its cooler outer layers, it cooled and condensed into dust grains, forming the light-blocking cloud that covered approximately a quarter of Betelgeuse's surface. Hubble's ultraviolet light spectroscopic studies, initiated in January 2019, were instrumental in piecing together the sequence of events leading to Betelgeuse's dimming. These studies detected dense hot matter moving within Betelgeuse's atmosphere before the dimming event. Concurrently, ground-based telescopes also observed a decrease in Betelgeuse's brightness, particularly in its southern hemisphere, around December 2019. Initially, the ejected matter was brighter than Betelgeuse itself, but as it expanded and cooled, it transformed into a dark cloud. This outflowing matter, along with the dark cloud it formed, contributed to Betelgeuse's sudden dimming. This astronomical event, marked by a colossal explosion, thrust Betelgeuse into the forefront of astronomical investigations, captivating the attention of astronomers worldwide. Betelgeuse emitted around 400 billion times more mass than the usual amount released in a standard coronal mass ejection. This event, which ejected material weighing several times more than the Moon, was significant for understanding both Betelgeuse and the workings of stars in general. Such a massive expulsion of matter has significant implications for our understanding of Betelgeuse and supernovas. Normally, red supergiants like Betelgeuse are believed to shed mass steadily before their eventual explosive end. However, the scale of this ejection challenges this notion, suggesting a more turbulent and uncertain conclusion to these stars' lives. This extraordinary event raises questions about Betelgeuse's future. Could it be preparing for a supernova explosion? Some studies speculate about the timing of such an event, suggesting it might occur sooner than previously thought, possibly within a few tens of years rather than a few thousand. Betelgeuse is not just any star. It's a giant zooming through space at a whopping 67,000 miles per hour. Imagine that speed compared to the stuff floating around it. This creates a bow shock, kind of like the waves made by a fast ship's bow. This cool effect happens when the star's outer layers bump into gases and dust in space, showing us how active and lively Betelgeuse is in its cosmic neighborhood. But that's not all. This bow shock isn't just pretty, it's also a treasure trove of knowledge about Betelgeuse's past and future. Scientists have noticed that after shooting out some material, Betelgeuse's surface cooled down and got less packed with stuff. This means the star is still a bit shaky even years later. The mystery deepens when we look at what's happening inside Betelgeuse. Models that mimic its fluid movements show a connection between how it stirs things up inside, throws out stuff, and then changes how it beats like a heart. This connection between internal processes and observable changes is a key aspect of understanding Betelgeuse's behavior and future. In conclusion, Betelgeuse's enigmatic behavior continues to captivate astronomers and stargazers alike. The recent observations by the James Webb Space Telescope and the Hubble Space Telescope have provided invaluable insights into the dynamics of this dying giant. As we continue to study Betelgeuse, we are not only unraveling the secrets of this particular star but also gaining a deeper understanding of the life cycles of stars in general. Whether Betelgeuse's recent activity signifies an imminent supernova or is merely a transient phase in its complex life cycle remains to be seen. What is certain is that Betelgeuse will continue to be a focal point of astronomical research and a source of wonder for generations to come. Here's the paragraph based on the lines you provided. The pulsating heart of Betelgeuse, with its constant changes and uncertainties, prompts us to ponder what lies deep within and what might unfold next. Betelgeuse appears to be shedding mass faster than many other stars, suggesting a complex internal dance where pulsations driving this weight loss encounter obstacles in the form of energy lost through heating and material ejection. This erratic behavior paints Betelgeuse's life as a turbulent roller coaster, challenging scientists to rethink star evolution. Amidst these changes, one wonders if Betelgeuse is on the brink of a supernova, a question of immense importance. Despite advancements, the exact timing remains elusive, yet the recent massive mass ejection has sparked intense speculation. Meanwhile, another celestial event, supernova SN 2023 ISF in Messier 101, has captured scientific attention with its unprecedented proximity and detailed observations revealing insights into the final stages of a star's life cycle.